So today's lesson is on angle relationships in triangles. So before we begin, there are a few basics that we need to go over before we look at some really challenging geometry problems. So you may remember from previous math classes that the interior angles of a triangle, those are the inside angles over here, here, and here, A, B, and C. So no matter what triangle you're looking at, all of the interior angles are always going to add up to a certain number of degrees. And so that number is exactly 180 degrees. And that's a helpful relationship because it will help us to solve maybe a missing angle in various problems. Some other helpful tidbits to remember are some relationships that exist between side lengths and angles if we're looking at scalene, isosceles, and equilateral triangles. So for example, if I see that a triangle is scalene, then if I want to get one of the angles, I need to know what the other two are. Or I need to have a way of knowing what two out of the three angles are to find the third. An isosceles triangle, you'll remember that we have two sides that are of equal length. And so that's indicated by these little marks on the side. That's telling me that this side has the same length as this side. That can be helpful in geometry as well, because by knowing that this side is equal to this side, that also means that the angles that are right across from those sides are also equal to each other. So in other words, this angle right here will be the same as this angle right here. And lastly, in an equilateral triangle, well, if you remember that all three angles in an equilateral triangle have to be equal, that's because, if the three sides are equal, then the opposite angles also have to be equal. Then to find out what any one of those angles is, I just take the total number of degrees that all three angles have to add to and divide that equally between the three angles. And so I know that each angle in an equilateral triangle is going to be exactly 60 degrees. So this angle right here is 60 degrees. This angle right here would be 60 degrees, and this last one here is 60 degrees. And that adds up to 180. So I'll get into that as we move on. Okay, so remember this angle right here has to be the same as this angle, but this third angle right here will be different than the other two angles. We'll see how we put that to use. Okay, so we can also look at the exterior angles of a triangle and see what they add up to. So for instance, when I'm looking at this, I can see that I have supplementary angles here. So this whole thing, I know that it will be 180 degrees, right? And so if I know the value of the inside angles, let's just pretend for a minute here that this is an equilateral triangle. So if this is an equilateral triangle, I know that each interior angle is going to be 60 degrees. And this will be 60, and this will be 60. And that adds up to 180. But the exterior angles don't necessarily add up to 180 degrees. Let's see what they have to add up to. So if I'm using my supplementary angles, right? I know that this whole straight angle right here has to be 180 degrees. So I can find out this little bit, angle 1 right here, by saying, well, 180 degrees minus the little 60 degree part. And that tells me that angle 1 has to be 120 degrees. And since each of the interior angles is 60 degrees, each of the exterior angles is 120 degrees. Okay, so let's look at that. Well, 120 plus 120 plus 120 gives me 360 degrees. So there I go. And that's another important relationship that will help us when we're problem solving in geometry. Although it's not necessary, those of you that have a strength in algebra may find it useful to create an algebraic equation that you then have to solve. That may help you in order to figure out an unknown in a particular geometry problem. I'll show you what I mean. So in this example right here, I have a right-angled triangle. Now I usually start out by trying to fill in any pieces of information that I can figure out that are not necessarily spelled out for me. So for example, I can see that this angle right here, the box, well, that tells me that that is a right angle. That's 90 degrees. So I might write that in. Okay. So I know that all of the angles, this angle, my right angle, and the unknown angle y, because it's a triangle, they all have to add up to 180 degrees. So I'm going to put my 180 degrees on one side of the equation. And then I'm going to write an expression to solve for y. So I know that y plus my 90 degrees plus my 34 degrees will all give me 180 degrees. That should all add up to 180 degrees. So, you know, some of you may prefer not to think about it in terms of geometry, but think about it in terms of just simple sort of addition, subtraction. And you might say, well, I'm going to figure out what y is by saying 180 degrees minus the other two angles. So minus 90 degrees and minus 34 degrees. So really the two ways of going about it will give you the same answer, so it doesn't really matter. Pick which one that you feel most comfortable with. So when you work that out, the remainder is 56 degrees, so the value of that angle y is 56 degrees. I'm going to model the second example using algebra again. Some of the examples you'll see will have some more complicated algebra, so it's not a bad idea to become accustomed to setting it up as an algebraic equation, and that will help you later on. However, you know, ultimately I want you to be able to problem solve to get the right answer using whatever strategy makes sense to you. That's my preference. So when I'm looking at this at any example involving geometry, I look to see, well, what pieces do they give me and which ones will I need to figure out. So, you know, I usually start with the pieces that I know the most, or stick out the most to me. And what's sticking out the most to me is the fact that I have a straight line here. Okay, so anytime I have a straight line, that's a straight angle, and a straight angle is equal to 180 degrees. So I know that whatever b is, if I add that to 120 degrees, the rest of it, that should total 180 degrees. Another way to say that is that I know that angle b is going to be the whole line, 180 degrees, and I'm going to subtract the 120 degrees on the outside, the exterior angle. And that's going to leave me with a value for b of 60 degrees. Now, I find if I don't put information in my diagram, I sometimes forget that I have that. So another strategy would be simply to just fill in the pieces of information directly in your diagram as you get them. So here's 60 degrees. And now the only piece of the puzzle that I need is this angle A. And so I see that I have a triangle, and I'm going to see if I can use that. Well, I have this whole triangle right here, and I have two of the three angles, and so the only thing required for me to find A is to remember that triangle sum relationship, right? All of the angles in my triangle are going to add up to 180 degrees, right? So that means that whatever A is, plus the 70 degrees in the top angle, plus the 60 degrees in the bottom angle, will give me 80 degrees, right? So really what I'm doing is I'm saying, well, 180, and I'm going to subtract the other two angles. Okay, and so that leaves me with 50 degrees, and so I've solved this geometry problem. So in this example, there are some markings on the diagram that I need to pay special attention to. And those markings are the fact that these two sides right here are equal. And so that makes it an isosceles triangle. Now that's important for me to consider because that automatically tells me that the angle opposite to those sides that are equal to each other. So for instance, if this angle across from this side is 68, then that means that this angle down here across is also equal to 68 degrees. Has a measure of 68 degrees. Okay, so that's, all that's really important for me to think about. I'm going to get rid of some of this and just make it a little neater. 68 degrees. All right, and so, but that, I don't care about that. I wasn't really looking for that, but this is an example of a question where I have to find out some other tidbits before I can actually solve for what I'm solving for. The question asks me to find out B. So I need to put the pieces together to figure out what B is. And so right away I notice that I have this triangle, this isosceles triangle, and that's important to consider. But then I also have a straight line here, and that's also important to consider. So my train of thought is that if I figure out what this little angle up here is, then I know that that angle plus my unknown B has to total 180 degrees. That's my strategy. Let's see how it works. All right. So I'm going to get rid of this and this. And my job right now is to find out what this angle up at the top is. All right, so I know that I'm going to give it a name. I know there's no name in here, but let's just give it a name. That's what you can do if you don't know how to refer to it. Just give it a name. So I'm going to call this angle A. Makes sense because I've got another B there. So I can find out what A is by saying, well, I know that A plus the 68 plus another 68, or 2 times 68 degrees, that will give me 180 degrees. Right? So, working that out, really all I'm doing is I'm saying A is going to be 180 degrees, but I'm going to take away the 68 degrees that I see in the 2 other angles. That gives me a remainder of 44 degrees. So I'm going to write that in where I had A, 44 degrees. Right? So I'm not quite done because, again, the problem is asking me to solve for B, and I haven't found out the measure of that angle B yet. All right, so I know that angle B and the 44 degrees are supplementary. They add to 180 degrees. Right? So angle B plus the 44 degrees. Those combined will give me 180 degrees. But really what I'm doing is I'm saying, well, angle B will be the difference between the whole straight angle and the 44 degrees. So 180 minus 40 gives me 140. I'm going to take away 4 more, and that's going to give me 136 degrees. And so now I have the value of B. I've solved that problem. So at this point in the lesson, you've seen a couple of examples. It may make sense for you to try this on your own first, and by pausing the video and then see how I take it up. All right, so no matter when I'm solving problems in geometry, I look at what I know and what I don't know. So certain things like straight lines, like intersecting lines, and indicators of a right angle, those are all pieces of information that are there, but they're not jumping out at me. So it's important to just find out, try to see those in the diagram and see if they can be helpful at all. All right, so you may, when you look at this, think, oh, that's a lot of busyness going on. So I always recommend that students use highlighters if they find it overwhelming to see a bunch of different figures or shapes in the same diagram. So I'm going to focus my eyes right now on this triangle right here. Okay? And the reason that I'm doing that is because they're asking me for angle D. And so in order to find out angle D, I need to know this other little angle right here, and I'm not given that piece of information. So what I'm going to do is I'm going to say, well, is there another way that I can find it out? Well, looking at this diagram, I can see that I have a straight line. So there's 180 degrees that I can work with. And so if I find the difference between the 95 and 180, that the leftovers will be this little angle here that I need in order to figure out what my unknown angle D is. So that's going to be my approach. So I know that this little angle right in here is going to be 180 degrees minus the 95 degrees. So 180 degrees minus 90 will give me 90. And then I'm going to take away 5 more, so that's 85 degrees. Again, mental math is awesome. Don't feel like you need to rush to get your calculator all the time. So I have 85 degrees right here. And so I also know that all the angles in a triangle have to add up to 180. So that's an easy way for me to figure out this angle right here, angle D. So I know that 180 degrees minus 85 degrees, and then I'm going to take away another 64 degrees, and the remainder will give me the value or the measure of angle D. So double checking with my calculator. If you feel like you need to, just to be extra safe, I can tell that angle D has a value of 31 degrees. So I'm going to put that in. So I've solved for D. D is equal to 31 degrees. All right, I'm going to get rid of this highlighted part here, and we're going to focus on figuring out what angle C is. So there are a few different ways that I can go about this, and in fact there may have been other methods to figure out other angles as well, right? So I could have just as easily started with angle C, and that would have been completely fine. That's kind of the wonderful thing about this. Multiple strategies. All right, so now I'm gonna highlight all of this right here. All right, so if I highlight all of that, you can see this big triangle here. And I know because there's this box here, that tells me that that angle is exactly 90 degrees. Right? And so again, I'm looking at a situation of triangle sum. I've got a 90-degree angle here, that whole big angle. I've got this 64 here, and the only unknown for me is angle C. So really, angle C is going to be that 180 degrees minus 64 degrees and minus that other 90 degrees. So when I work that out, that gives me a value or a measure for angle C of 26 degrees. All right, so it's important for us to do an example that involves algebra because in looking at some past EQAO math exams, I did notice that there were questions that it did involve algebra. So I think that you'll find if you understand the basics of algebra and you understand the basics of the geometry, putting the two together is not terrible. Okay, so it's again just recognizing what relationships exist and putting those to work. All right, so in this case, we're not representing the whole angle as a variable. We're representing each angle as a polynomial expression, right? But it doesn't matter because I know that all the angles will, in a triangle, still add up to 180 degrees, right? It's just that I don't know what those values are. I just know that they all add up to 180 degrees. So I'm going to write out an algebraic equation that involves the expressions that were used for the angles, right? So I'm going to say, all right, well, let me see. I'm going to start with angle A. So angle A is 4x plus 14. I know that that plus the other two angles will give me 180. Angle B is 5x plus 4. And the expression that was used for angle C is 6x minus 3 plus 6x minus 3. All right. So I can see some like terms here. I've got some variable terms, all the ones with x's that I can simplify. So when I look at that, well, I have 4x plus 5x, okay, that gives me 9x, plus 6 more x, that gives me 15x. Next, I see that I have Ooh, bouncy balls. Next I see that I have a plus 14, a plus 4, and a minus 3. So let's work that part out. So I see that I have 14 plus 4 is 18. Minus 3 will give me 15. So plus 15, and that's equal to 180 degrees, right? All right, so now I'm going to use what I'm going to remind you of some algebra. If I want to isolate my variable x if I'm to solve for it. And so that means I need to get rid of this plus 15 by subtracting it. And I'm going to subtract it on the other side as well. That will leave me with 15x is equal to 180 minus 15. So 15x is equal to 180 minus 10 is 170. Minus 5 more will give me 165. Okay, so now I still have an isolated x. I don't know what the value of x is. So I'm going to divide the 15 out. Remember I'm multiplying x by 15, so I'm dividing by 15 to get rid of it, but I'm going to do the same on both sides. So that will allow me to isolate x. And if the numbers are too big for you to do this mentally, then make sure that you use your calculator to do that. And that gives me a value of 11. So there, I've solved that problem. The value of x is 11. So it's just, remembering the details of algebra. So I've highlighted some questions for you to practice to help you strengthen your skills with this. And remember, if you have any questions, I'm always available over the lunch hour.